And get rolling for today, okay? Hopefully everybody got a chance to write that down. If not, I'll come back to it later on, okay? All right, first thing, we got to define a couple things here, coordinate and congruent. Coordinate, this is the location of a point, okay? Do a quick recheck here. How do I symbolize a point? A dot. Very good. Use a dot. Okay. So you guys just came out of Algebra 1. My understanding is you guys did some graphing in there, correct? Yeah. You know, graph a line and a parabola, maybe. Try to, right? All right. So check it out. Here's my Algebra 1 review in 30 seconds. Okay. All right. Coordinate points on a graph are written x, y. Correct? X is the first number you see. Y is the second. The x's move, where you can see it. The x's move left to right. The y's move up and down. Later on in your math career, they'll tell you fancier ways to describe it. For now, that's how we're going to describe it. Okay? The first number you see tells you to move left or right. The second number you see tells you to move up or down. So if I gave you a coordinate point that was -3, 5, correct? You see a negative number first, you're going to move to the left 3 units. Positive number second tells you to move up 5 units. Okay? Right? So, to the left 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. There would be a coordinate point, -3, 5. Right? One last thing, in case we need to go over it. The quadrants start in the upper right-hand corner, go counterclockwise. First quadrant, second quadrant, third quadrant, fourth quadrant. Okay. So there is, I don't know, 3 weeks of material from Algebra 1 in 2 minutes. Okay. 45 seconds. Congruent. All right. My first promise to you of the year. My first promise to you. I promise you, if you don't know what congruent means, you won't make it through this class. True story? True story. Okay? If you don't know, if you don't memorize what congruent means, you won't make it through this class. And it's a very simple definition. Identical measurements. Okay? Identical measurements, that's the basics of congruence. Identical means the same or equal. Okay? If I say things are congruent, they are the same or equal or identical. Okay? So here, we're going to do this. It's Friday, we're going to play our little game. I'm going to say congruent, you're going to say identical. Congruent. Good. So we have to do it once. Okay? Congruent simply means identical. All right? I'll give you an example. I give you a ruler, and I said, you know what? I'm not. I'm going to do that later. Never mind. I'll do it later. We'll move on. Okay? Congruent means identical. We'll come back to that throughout the lesson. Okay? Constructions. Okay, construction is just a representation of a segment, angle, or shape. I wish we did more constructions in here. There's a lot of things I wish we could do more of. Maybe if y'all came to school on Mondays, we'd do more of that stuff. But if you'd rather come to school on Mondays and do constructions, raise your hand. Raise your hand. So that's what I thought. Okay, construction just means hands-on way of doing things. Okay. You guys make constructions. If we made constructions of a triangle, we measure the triangle. We take our little scissors out, cut out the triangle. Okay, we color it. Right, we post it up in the room, and whoever came in here would be like, "Oh man, that's a great feature." All right, we don't do it. So instead, boring. Everything's just boring. Boring over the out. All right, so the reason I don't do it, when you get to your EOC, here's a newsflash for you. They're not going to have you have scissors and make constructions and cutouts and everything like that, okay? The way I teach it to you guys is as close as I can get. I will do it on the POC. POC, they'll give you a diagram, and then it'll have, hey, we're trying to make an angle bisector. What's the third step involved here? Okay? And, you know how to do that yet, but that's how we'll learn about construction. All right? All right, here's the big one. Midpoint. Bisect and segment bisector. The midpoint of a segment, and when it says segment, think line segment, is the point that bisects or divides the segment into two congruent segments. All right, let's try that one again. What is congruent? Same. One person. What's congruent, guys? Identical, the same, equals, any way you guys think of it, okay? Like geometrically, here's what that looks like. If I have the ruler, let's say my ruler starts at 0, goes to 12. Perfect. 0, 12. If I asked you to find the midpoint of that ruler, where would the midpoint be? 6. Perfect. How did you get 6? You took 12, divided it by 2, correct? 12 divided by 2. You take your total length, find your midpoint, take your total length, divide by 2. It really is that simple. We make it more complicated when we put it in a coordinate graph, and we have to find midpoint formula and distance formula, but think about this. If I said, if I said halfway between 0 and 12 is 6, all right? This is our geometrically what that means. How many units are there from 0 to 6? 1, 2, 3, 4, 5, 6, right? I got 6 units here. Okay, how many units are there from 6 to 12? 7, 8, 9, 10, 11, 12. 6 units. Okay, I've just defined for you a lot of this. The midpoint is 6, right? It has split that total length of 12 into 2 congruent segments. 6 units and 6 units. Right? Okay. Let's say that we weren't using a ruler. Let's say we're actually using what we've been doing so far, like line segments, right? I define these as point A, point B, we'll call 6, we'll call this point C. Okay? A segment bisector would be a segment that cuts something in half. So if I said DCE, right, and I knew that C was the midpoint, that means DCE is the segment bisector of ACB. All right? It's a lot easier to work with this material than it is to define it. So it might sound strange to think about that at first, but the more we do it, the more it becomes second nature to you. Okay? Right? If I put all this on a graph or in a shape, right, you guys would be able to handle it, I promise. Okay? If I get that, go to the next one. Degrees. Okay? Angles are measured in degrees. Let me give you a quick recap of angle. We defined angle, and we said that when a line segment or array intersects with another line segment or array, the point of intersection is called a vertex, and an angle is formed. We measure those angles in degrees. If this kind of gets us down the road a little bit, there are 360 degrees in the circle. So 1 degree is 1 over 360 of the circle. right? We will be measuring angles for now, okay? So for example, we'll talk about line segment A, B, C, right? And I'll make that, what do we call that right there, guys? Ray, okay? So line segment AB for BA meets ray AC. You'll see that hand. We're going to get back to it in just 1 second, okay? We said we could name this angle 1, and we would measure it. We'd say, let's say it's 47 degrees. Okay? Yes, ma'am. It won't. Okay, for about 10 more seconds, we'll get on to the good stuff. Good stuff's coming up. Ready? Nervous? Okay. You're not nervous. All right, here we go, guys. Got it? You got it? I'll come back if we need to, okay? Oh, segment addition postulate. Just got real. Yeah? Okay. You do not have to write this down. I'm not going to make you define segment addition postulate. As a matter of fact, I'd rather you just look at it and make sense of it for now. Okay? Like how, listen to how I explain it. It's actually pretty logical and fairly simple. If I add the distance from A to B to the distance from B to C, the sum would be the total distance from A to C. Very simple, right? Let's do a real life application. Okay? We're in Tallapoosa, correct? Once upon a time, you could drive on 78 to get to Atlanta. Okay? Some of you may still do that rather than I-20. It takes a lot longer, but you can. Okay? Like if I take the distance from Tallapoosa to Douglasville and add that with the distance from Douglasville to Atlanta, I get the total distance from Tallapoosa to Atlanta, right? Correct? Okay. Same, that's all we're doing over and over and over, okay? One thing you're going to see, okay, let's say we went from Tallapoosa to the next town past Douglasville, Austell, maybe not, okay? We go from Tallapoosa to Austell, and that is 20 miles. And then we go from Austell to Atlanta, and that's 20 miles. Austell is the midpoint between Tallapoosa and Atlanta, right? Remember, midpoint cuts a total distance in half. If the entire distance would be 40, and I've cut it into two congruent or identical 20-mile sections, that means that I have this down the midpoint. Okay? All right. Here is my first tip of the year. I've got a word problem. Anytime you get a word problem in this math, draw a picture. Okay? Draw a picture and make life easy. G, which is a point, is between F and H. Stop right there. G is between F and H. How am I doing so far? Am I right so far? Have I done exactly what the problem says so far? We're good. It says that F to G is 6, and F to H, the total distance, is 11. So, what would G to H be? I would be, they'd fire me if I didn't do it this way, maybe. I don't know. They teach somebody the way. You have to have a variable in there. You have to do algebra all the time. You really don't. How can you find 5? 11 minus 6. Right? Real simple. But if we said 6 plus x equals the total distance, which is 11, I'm doing the exact same thing That's my segment addition postulate helping, right? I'm adding the segments together to get the entire segment. Okay? Here I'd subtract 6 from both sides. X would be 5. Very simple, right? Very, very practical, simple things that we piece together the entire year. Start off by drawing a picture. Add in the information. Figure out which postulate or theorem you use and solve. That's what this class is going to be over and over and over again. Okay? Sometimes it's easier than other times. Here it's pretty easy, right? Not too hard. Yes, ma'am. It depends. If it's a word problem, I'll let you draw a picture. If it's already given to you, work it out. Well, I tell you what, I'll make it harder sometimes. Okay? All right. So work this one out right now. Okay. Let's take a couple minutes here. Go ahead and get started with it at least. Write down the example. Most of the time to answer your question, if it's as easy as the one I gave you the first time, you can just give me the answer. If it's difficult like this, you're going to want to write it down. Okay? I'll show you how to set it up. I'm not going to say anything else, and you solve it after me, okay? Check yourself. If you set it up the same way, you're going to do both. If I take the distance from N to M, which is 17, so that's N to M, and I add it with the distance from M to O, add it with 3x minus 5, it will equal the total distance from N to O. Okay, which in this case is 5x plus 2. After that, I'll simply solve or find x. Okay. So, if you set it up that way, great job. Go ahead and finish the problem out. If you didn't, make sure you got that part in your notes and continue on from there. Okay? All right. I'll work it out here in just a couple of seconds. All right, last teaching period I got today is we're in it now. Okay, watch how I work this out, guys. First thing I want to do for me is isolate my variable. I'm going to subtract 3x from both sides. Okay, I get 17 plus negative 5, and I write it that way for a reason. I'll tell you why. 2x plus 2. Okay, if I take the symbols, the operations, and just bring them down, I can then kind of regurgitate that information. In other words, I can say, wait a minute, that doesn't really make sense, but 17 plus negative 5 is the same thing as 17 minus 5, which is 12. Okay? 2x plus 2, I subtract 2 from both sides. Hopefully none of that is foreign to you. I divide both sides by 2. 2 unbind my variable, get 5 as my answer. Okay? That's what you should have had for this particular problem. Right? Sometimes your problems are going to say, hey, solve and find the distance, find the measurement of M to O. In that case, I got to take 5, plug it in right there. 3 times 5 is 15. 15 minus 5 is 10. I'm good. Okay. First step is going to be solving for the variable. Right. I'll come back to it if you need it. Ooh, here's a good one. Here's a good one. Okay. D is the midpoint of EF. E to D is where it's plus 6, and D to F is 7x minus 9. Find E to D, D to F, and E to F. I'm actually just going to show you how to set this one up. Okay? There is a crucial definition that you've got to understand. Midpoint. My midpoint takes a line segment and divides it into 2 what segments? Congruent segments. And congruent means the same or equal, right? If D is the midpoint of EF, or it means that E to D is congruent to D to F, which means this distance of 4x plus 6 equals 7x minus 9. Okay? I have to know my definition of midpoint to understand all of that, right? You'll see that? You got to know what the midpoint means for us to understand that. Okay? I'm not concerned about solving it from there. We've done that a couple times today. Like I said, that's from here it's algebra that takes over. I'll let you do that on your own. Okay? One last big one, last thing for today. This is called the angle addition postulate. Okay, I'm going to review it with you. In their example, they have a big angle, PQR. Okay, now I'm going to do a check. I'm going to check with you here. Q to S, Q to P, and Q to R are all what? Line segments, or rays? Rays. See that? They're all rays, okay? Right? It's okay if you have all of these creating an angle. That's okay. All right? Look at my big angle, PQR. Right? I can take the measure of PQS, which is in red, and add it with the measure of SQR, which is in blue, and I would get the big angle measurement. Not that hard, right? In their example, or in this example that I've given you, the measure of DEG, the whole angle, is 115 degrees. Okay? DEF, just the smaller angle, is 48 degrees. How do I find FEG? That's the question. Okay? You do it a couple ways, right? You'll see how it's the exact same setup as the line segment, right? Okay. If I add, so yes, you're going to end up subtracting 48 from 115. When I set this up, if I just say 48 plus x equals 115, I then subtract 48 from both sides. Okay, I messed this up already this morning. I won't do that here. X would be what? Let's subtract it. 67. Okay. 67 plus 48 is 150. I put 57. We did it on calculator. Checked it right. It is 67. They didn't like it. Good. Really good math. Sorry, guys. All right. Any questions on that?